So investigators know the Kingpin failed. But was it a casualty of the collapse or its cause?
What we have is the full length of the Kingpin. That's the top.
In a lab outside Milwaukee, engineers with Stork Technimet try to piece together what happened to that Kingpin. The process begins by carefully cataloging and photographing each fragment. The photographs are akin to police mugshots. In this case, each metal fragment is a suspect. Did some small flaw in the way the Kingpin was manufactured lead to the disaster?
The Kingpin bent and the bottom sheared off.
Craig Brown is a metallurgical engineer at Stork Technimet.
It's important to know exactly how the metal tore as the bottom portion of the Kingpin was sheared off. Several samples were taken from different locations within that section so that we could do a complete evaluation.
The first sample Craig takes is called a macro sample. A pizza-shaped cross-section of the Kingpin is cut and analyzed for small cracks in the steel structure. Then core samples are extracted from the Kingpin. These are stretched to their limits to determine the tensile strength of steel across the whole Kingpin section. The last sample is taken directly from the part of the Kingpin that was sheared off.
A section was cut from this area that allowed us to evaluate the microstructure on both the Kingpin body and the sheared off section so that we could see what the structure was at high magnification.
Technicians use a scanning electron microscope to check for tiny fractures that may have weakened the steel in the Kingpin. They peer deep into the fracture surface to determine exactly how the metal tore apart.
We were able to show that the material tore in a ductile manner, which is a good fracture mode. It wasn't brittle, it wasn't improperly heat treated, so that showed that the material was proper for that application.
The results exonerate Big Blue's fractured Kingpin.
Knowing that something is good is just as important as knowing that there's something wrong with it. It's all part of the puzzle that we have to put together.
Now investigators know that the accident was not caused by a failure of Big Blue's boom or cables, and there was no structural flaw in the crane's Kingpin. So they turn their attention to suspect number 2. Could Big Blue have been brought down by the ground beneath those 2 massive transport crawlers? When she arrived at Miller Park, the citizens of Milwaukee nicknamed her Big Blue. But her real name was the Transy Lift 3, and she was built here by Lamson Crane International. The company's facilities in Kennewick, Washington, are a jumble of booms, cabs, and other assorted pieces of blue steel. Cranes and more cranes.
We don't try and do everything. We try and do what we're good at and be the best we can at that. We've got excellent equipment, excellent people, good techniques.
Transy Lift 3s have been operated safely around the world for more than 2 decades, lifting huge pieces of material into place for oil rigs and nuclear power plants. What makes these cranes unique is obvious: size.
As you see the machine behind you, you see that it's quite large, and this is just a middle-sized machine from our fleet. We have made many, many lifts that exceed 1,300 metric tons for a single crane. And the majority of the time, you know, those are made at large radiuses and large heights.
Once assembled, the Transilift 3, with its main mast extended as much as 567 feet, operates like a gargantuan teeter-totter. More than 1,000 tons of counterweight keep the structure from toppling as it lifts a load as heavy as a stadium roof section.
The geometry and the physics of it are very, very simple. You get a counterweight a long ways back, you can pick up a load a long ways away.
The Transilift sits atop two massive crawler transporters that allow it to move with a load. While it's in motion, the counterweight can be moved independently in any direction to balance the load.
What that gives us is the ability to do multiple operations simultaneously. We can travel the machine and swing it at the same time.
The Transilift's credentials made it the perfect crane to do the job at Miller Park. Giant roof sections assembled on the ground could be picked up and transported to the stadium within the tight confines of Miller Park. But on July 14th, 1999, the huge crane came tumbling down. Investigators know it wasn't the Kingpin. And thanks to the video, they have also ruled out mechanical failure in the boom of the crane. Then, a few days into the investigation, they make a surprising discovery.
Our testimony indicates that there was actually a ground failure early on in the day, which had the crane actually sinking into the ground by some accounts up to a foot when they did the pick.
As a result, the initial pick was stopped and a new route was planned to avoid the problem area. But the question remains, if the ground had settled under Big Blue earlier in the day, is it possible that the same thing happened again later? Could the ground beneath Big Blue have caused the disaster?
It's very important for a crane of this height to be on extremely level ground, because any unlevelness of the ground gets magnified over the height. For this particular crane, the criteria was 3/4 of an inch over a distance of 30 feet. The ground had to be within that tolerance. Otherwise, there was a danger of the crane tilting too much.
To make certain the crane is level and its weight is distributed evenly, concrete runways or mats are built. In the aftermath of the disaster, Big Blue's crawlers and concrete mats remained more or less intact. Investigators test those mats and the soil underneath to determine what role, if any, they may have played in the disaster.
And there were cracks that we noticed that were small cracks, hairline cracks, that were associated with where the crane actually sat.
Each crack is thoroughly examined and mapped. Engineers also hunt for hidden air pockets in the soil below the mats that might have affected the stability of the pad. The high-tech hammer functions like sonar. Sound waves bounce back, exposing any hidden anomalies. Their exhaustive search turns up no evidence that there was a problem with the concrete mats. But the mats are only as good as what they're sitting on. The answer may lie deep below ground. Investigators are concerned that even though the mats are intact, the ground below may have been compressed by the weight of Big Blue, but then sprung back to its original position, erasing any indication of a problem. Probes are used to measure the elasticity of the soil.
Go ahead.
Hydraulic jacks measure how much weight the soil can bear. Was Big Blue too heavy for the concrete mats and the ground beneath them?
There was no evidence of just gross failure of these mats where one could just draw the conclusion that that this was a simple case of a foundation issue.
Another dead end. Ground settlement did not topple Big Blue. Working down their list of suspects, investigators seem to have only one option left, and it's the video that gives them the final clue.
There are a lot of things going on in this video. For one thing, keep your eye on the flag in the upper right and watch the changing wind direction. You can see that it's changing dramatically over a short period of time.
That clue takes investigators down a whole new avenue. And along the way, they discovered the astonishing oversight that brought Big Blue crashing down. July 14th, 1999. Charlie Christie and his radio operator sit on top of Big Blue, running the giant crane's tugger winches. A wind blows through Miller Park, a wind that made Charlie Christie and his colleague uneasy.
And he says, "You feel that?" And I says, "Yeah, I feel that." I says, "That's the wind." When you run crane long as I have, you can feel that. It's like a vibration. It's like if you stick your hand out the window of a car at high speeds, you can feel that vibration that you get from it. It's the same thing.
Wind is every crane operator's worst nightmare, even with a crane the size of Big Blue. Although it carries 1,000 tons of counterweight to balance the load, that does little to counter the effects of wind blowing on the sides of the crane. Measurements taken at a nearby airport shortly before 5 p.m. on the day of the accident showed winds of 20 miles per hour, right at Big Blue's upper safety limit. But this doesn't tell the whole story.
The specifications for the crane said that the crane should not be used in wind speeds of over 20 miles an hour. That was considering only the wind on the crane itself, and not even considering the wind force on the piece that's being lifted.
The piece in question that day was a 450-ton roof section. At first glance, it looks as though the wind would just blow right through it. But experts calculate that the roof section had more surface area than the wing of a Boeing 747. And somehow that detail was overlooked.
The effect of the wind on the piece that was being lifted apparently was never calculated for that particular pick or for any of the previous roof picks on this project.
Was this enough to bring the crane crashing down? To find out, investigators must try to calculate the wind loads acting on the crane and the roof section it was carrying.
It was a lattice work of shapes that the wind was going in and out of. So the challenge was to use the state-of-the-art analytical techniques to estimate what that might have been.
Investigators turn to the experts at RWDI in Guelph, Ontario. It's one of the top wind engineering firms in the world. They recreate the accident in miniature, inside a wind tunnel. Scale models of Big Blue, the partially completed stadium, and the roof section are made in precise detail. Each piece of the model is mounted so that the effect of the wind can be measured precisely.
In this test, each of the crane and the roof panel was mounted on a separate force balance. And by testing these two items at the same time, then we can get an idea of the total wind action that was acting on the crane at the time of the incident.
Investigators recreate the changing wind conditions on the day of the accident. Sensors measure the invisible forces acting on the models. A smoke wand helps technicians see what the wind is doing. After 4 days of testing, they pass their data along to David Peraza to interpret.
Due to the direction of the wind and the sail effect on the piece that was being lifted, the crane was essentially subjected to a sideways load that was on the order of 2.5% to 3% of the load being lifted.
3% doesn't sound like much, but investigators estimate that the combination of the wind and the sail effect on the roof section imposed an additional side load on the crane of 6.5 tons. And the wind speed on that day was already at the crane's upper limit. It was more than Big Blue could handle. It took more than 2 years to gather the data and piece together what happened at Miller Park. The finished product, a detailed account of Big Blue's last hours on July 14th, 1999. At 5:14, she carries a 450-ton roof section to the set point at the south end of the stadium. The crew begins lowering the massive piece into place. Inside the stadium, William DeGrave, Jerome Starr, and Jeffrey Wisher are waiting to bolt it into place. They're suspended in the cage of a smaller crane. The mammoth roof section is about 300 feet off the ground when the wind gusts and changes direction. Charlie Christie feels a shudder. As the wind hits the suspended roof section, it generates huge side load on the crane. More than Big Blue was designed to take. The crane's massive kingpin starts to bend, bolts snap, and the locking ring flies apart right before Charlie Christie's eyes. The roof section, the upper half of the boom, and the jib fall inside the stadium, killing William DeGrave, Jerome Starr, and Jeffrey Wisher. It's all over in less than 30 seconds. In the wake of the accident, the contractor responsible for building the stadium, Mitsubishi Heavy Industries of America, was heavily criticized. Why had they proceeded with the lift despite warnings about the wind conditions that day? Why had they not properly assessed the wind loads of the roof sections that were being lifted? In 2000, a jury finds Mitsubishi Heavy Industries of America 97% negligent in the tragic accident that killed 3 construction workers.
The lessons that can be learned from this accident were actually applied almost immediately as the project continued, was that you needed to explicitly take into account the wind effects on the piece that was being lifted.
As excited crowds file into Miller Park today, it's difficult to imagine the twisted steel and shattered concrete that littered this site not long ago. On the first base line, where so much of Big Blue fell, there is only the Brewers' dugout and thousands of excited fans.
But having been there, you know, you can't shake the picture of what you saw. I mean, I look at the batter standing at the plate, you know, and that's where the crane was down, in the infield over there, you know, and I can still see it. I can see the tons of rubble laying over there.
Outside the stadium, a bronze statue depicts 3 construction workers, a permanent tribute to the 3 men that died building Miller Park.